name is Dave Hart. I am the User Services Manager here at CISL, and today's talk is about preparing allocation requests for our upcoming university opportunity for large allocation requests. What we're going to cover today is we'll talk a bit about the current resources we have available. We'll talk about the range of opportunities that are available to university researchers. And then the bulk of the time we'll spend talking about preparing allocation requests and how to succeed at, with the panel review. First, let's talk about Cheyenne. That's our primary HPC production resource. It's going to be in production through 2021. It's an SGI ICE-XA cluster with 4,032 nodes. Long story short, it has about twice as many cores as Yellowstone did, meaning it's considerable more capacity available for university requests, as well as performing better for the same on a core-for-core basis. So in effect, you've got almost 3 Yellowstone equivalents according to our NCAR benchmarks. I showed a picture here of Cheyenne's ribbon cutting ceremony last August. Oops, sorry. And it was the ribbon cutting was timed to the city's of Cheyenne sesquicentennial. That's why it was named Cheyenne. A second allocated resource we deal with is Glade project space. So the Glade system currently has 38 petabytes of storage on disk. 15 petabytes of that is for scratch space. About 12 petabytes is currently set up for long-term allocated space. And then another 11 petabytes is set aside for collection space. This includes work such as from the RDA data collections, the Research Data Archive, or from the Climate Data Gateway data collections being CMIP data. But project space is what can be requested as part of an allocation request. So those are what you should focus on. Plans this year, though, include deploying a larger medium-term campaign data storage resource in mid-2018. This will be disk-oriented storage, but for, you could think of it as short-term archiving. Storage that you want to park something somewhere for a little while until you get back to it. That's going to be made available later this year, so keep an eye on our daily bulletin for news later on this year. Another point I wanted to make here is that the original 16 petabytes of disk acquired with Yellowstone will be retired at the end of 2018. So we aren't going to be discussing any more project spaces there. We're working with users to retire that storage space. We do still have data analysis and visualization resources. At the moment, the Geyser and Caldera systems remain available. But if you've been with us for a while, those were procured with the original Yellowstone system, so they date back to 2012. A refresh is coming this year, and we're well underway with that, but the details aren't yet finalized. The new systems will include current generation processors, large memory, and current generation GPUs. For the moment, though, you'll be requesting Geyser and Caldera time, and once the new resources are available, you'll be able to ask for, sorry about that, ask for transfers to those new resources. So stay tuned again for more news there. We also have our HPSS tape archive, and university users can still request storage on HPSS. However, you shouldn't be thinking about HPSS as a scratch overflow system. Tape you should be thinking of as your final preservation site for data that needs long-term storage. We are at a point where HPSS capacity is now budget capped, meaning users are generating data faster than CISL can afford to buy the tapes. It used to be that HPSS and tape storage was perceived as effectively infinite, but these days we are watching HPSS use closely to ensure we aren't forced into some budget corners. And because of our policies where university data primarily resides at CISL only during the course of your allocated projects, most of the university requests for will be directed to some form of disk storage, either project spaces in the short term or this medium term campaign storage I mentioned earlier. So consider that. A question about what's medium term, long term, that's hard to say exactly. Medium term, thinking 6 months to a year. Long term might be something that has to reside there for multiple years. The time frames there vary depending on the project. Okay, about the university allocation opportunities. First, I wanted to make sure I mentioned that we do always make small allocations to, and the requests are always accepted for those. Small is currently up to 400,000 core hours on Cheyenne. These small projects may require an NSF award, and these can be used for benchmarking or preparing your large request or just for completing the work that doesn't require a great deal of computing. A reminder to everyone that we do make small one-time allocations for graduate students and postdocs, and as well as new faculty who don't have an NSF award yet. For grad students, this is typically for a dissertation project. For postdocs, it might be an initial seed project for their research fellowship or to initiate their own line of study. And new faculty can use it as a seed project, again, as they prepare for their NSF awards. If you have a classroom allocation or a classroom need, we do make allocations there for instructional use. For most of these small requests, an abstract is all that's required. If you're making a small one with an NSF award, obviously we need to know about the NSF awards. And more details on these can be found at the allocations page on our website. The university large allocations is what we're talking about today. The next deadline is coming up near the end of March on the 26th. Large requests from university researchers are reviewed and awarded twice per year. So the next deadline would be in September. At each of these opportunities, we have 175 million Cheyenne core hours that need to be allocated at each opportunity. And as I mentioned, we will be capping the amount of storage that we can make available. And now I'm realizing I meant to provide some numbers today. But it is going to be capped. And I'll be providing numbers for those limits. But on the order for HPSS, it'll be on the order of a petabyte or so total for the opportunity. Probably a comparable amount for the campaign storage. So this really affects projects that anticipate needing hundreds of terabytes of storage. Those become challenging for the panels to review and make awards for on our LID storage resource. Related to these, we have posted updated instructions for preparing your request, and I will talk about more of those details later. But because of the limits on storage, the panel is giving large storage requests greater scrutiny. So again, the main point of my main update on this talk is to focus the increased focus needed for your storage needs, especially as your storage and data footprints grow. The Climate Simulation Laboratory is another opportunity we make available to university researchers. These are effectively an opportunity that allows you to make large-scale requests of 20 million core hours or more on Cheyenne, and tries to prevent the panel from always shrinking projects down to some small size. The CSL acknowledges that there are some projects that require large-scale access to resources, and this is the way to fit those in. These requests are reviewed only in the spring, this coming spring, and about 70 million core hours would be allocated to such projects. So a small number, but they can be substantially sized projects. A minor update to our policies for this. In the past, CSL requests have been limited to a 12-month period, but now if you have an NSF award that extends up to a longer time frame, we can award your CSL allocation for the length of your NSF award. This is basically consistent with our university practice for other CHAP reviewed awards, so this should help eliminate some confusion we had about what the requirements were for CSL. Okay, preparing allocation requests. This slide was put here to remind you, if you still think of us as having Yellowstone, just remember it was decommissioned in December after about 5 years of service, which actually in HPC terms made it quite the senior citizen. It was the longest serving HPC system at CISL in over 20 years. So again, an important point that I want to make here is the importance of considering how you are producing, managing, and using data during the time you're operating on our resources. The era of unlimited storage is over. On the university front, this isn't as widespread as it is here at NCAR, but it is important, and we are seeing more and more projects with very large-scale storage needs. So again, if you have modest needs, then I'll talk more about what modest might be. But if they're at the small end, it's less critical. But as you start seeing 100 terabytes of data being produced or even more, you should be paying more attention to how you're going to deal with that data. So along those lines, we're going to be seeing some changes this year for our storage resources. And I already mentioned, for example, the campaign storage, the limits on HPSS allocations, and similar activities. So we're in a transition phase this spring, so keep an eye on the daily bulletin that we send out for announcements and schedules as things become more crystallized. Down the road, we will help match up what you're asking for now to the appropriate resource that's on the floor later this year. But for now, you might think of things in terms of the optimal way you want to use our temporary storage, which is our scratch space. That currently has a 60-day retention period. We will have some access to medium-term storage, which today is called project space. Later, it might be called campaign storage. And then there's long-term storage, where, as a question was indicating before, campaign storage could also serve a long-term need as well as a medium-term need. But the tape archive is more definitely towards the longer end of the time scale. But also think about down the road, this data will need to be moved to some permanent home, possibly at your campus. So think about how your movement of data back to your campus will play into your work. So, right. There's a related question. It was about HPSS specifically. Sorry. Yeah. Request documents and instructions. So this is where I want to spend some time. This is what you'll be preparing. So I highlighted what is on the instructions page in the yellow box. And it's basically what I'm telling you today. I won't read that here. But the requests for university projects and CSL requests use essentially the same format. And the instructions are on the website. Again, if you have any trouble finding the websites, you can always contact CISL help at ucar.edu for assistance. And it should go without saying, but I'll say it anyway, that following those formats and instructions will get you the best results. The panel that reviews the request has helped craft these instructions and formatted them to ensure that they have all the information they need. And we even provide guidance as to how long each section should be, so you can help understand the priority that the panel reviewers give to each section. So in general, I think about our submission format as a 5+5 format. The main part of the document is a 5-page request. It has a very short project information section, a few lines there, a project overview and strategic linkages section. It's about a half page at most. A short section on your science objectives. This section is important, but a key part of your success is to put it in the proper context. The panel is not reviewing your science objectives. If you have a NSF award, and it is a requirement for applying here, the panel is accepting that your science is approved. What they want to understand is enough about your science objectives to understand whether your computational experiments in the next section will answer those objectives. So you can boil down your science questions fairly significantly as long as you provide enough detail in that to support why you need the experiments that you've proposed. The bulk of your first 5 pages should be on those computational experiments and the resource requirements to support them, the rest of the document there. In a supporting piece of the document, up to 5 more pages, you can talk about how you plan to spread this work over several years. This is, again, most important if your request is very large. And by very large, let's say 20 million or more over the period. When it gets to very large scale, the panel may say, well, we can't award all of this at one time because it will impact too many other researchers. So we'll only award you enough to complete what's planned in the first year. At smaller scales, a few million core hours, that's less critical. The data management plan is important. The key element here, though, isn't how will you use our resources, but how does your data management plan dovetail with what data you're producing and why you're producing them. So this is more your output, your final output data. What are you going to save? Why are you saving it? What do you need to keep in order to support your scientific findings? If you've computed here before, you also ask you for an accomplishment report, like how have you used your previous allocation, what publications were you produced, what were the findings that you got out of the computations you ran, and then finally you can include references and additional figures in the second half of the document, so to save some space in your first part of your 5-page request. Again, they're all laid out in the instructions and with extensive detail over how to provide each of these sections. So within those instructions, I want to make sure I give you some additional tips that may or may not be quite as obvious. Again, I already said this once, but focus most of your request on the computational experiments and the resource needs. They're going to ask you about the methodology, and in a lot of cases, this may be simple if you're using a well-known model such as CISL or WRF. The methodology is embedded in the model itself, and so in many ways, the bulk of that section can be very brief. But if you've are using particular aspects of the model or made changes to the model that affect the method's scientific approach, then those should be addressed there. The appropriateness of the experiments is another piece. So do your experiments proposed provide a necessary and sufficient amount of runs to address your scientific questions? A big piece here that will come up is in ensemble requests. How many ensembles are you requesting, and is that scientifically justified by for your methodology and in the literature that says these are how many you need to get statistically significant results, for example. Finally, the efficiency of resource use is important to include. You should provide ideally some benchmark numbers to say these are the types of runs I'm doing. I've run some sample runs on Cheyenne already. This is how much they cost, and I would scale those to the appropriate duration of the experiments to calculate my request. And don't forget to include how you came up with the size of your storage request as well. In a lot of cases, we're looking for these days, particularly as your data footprint grows, that you've given some thought to how much data you're storing and why you're producing that data. It's at the largest scales, it's no longer feasible to simply produce lots of data on speculation and expect it to be available indefinitely given the size at largest scales. So you may have to say what variables you are storing at what frequency, and is that supported and necessary to address your science questions. Another piece is remember your audience here. The panel members are computational Earth system scientists from the universities, NCAR, and elsewhere, but don't assume that they will always be experts in precisely your specialty. Make sure you bring it to appropriate level that colleagues in a closely related domain will understand what you're trying to address and that your methodologies are appropriate. You do want to articulate the relevance and linkages between your funding award and computing plans. Especially, this is most important if it's not obvious. If your NSF award, particularly the abstract available online, clearly indicates that you will be doing a set of computing runs to address a specific science question that's related in the proposal, you can spend time here. But if you're part of a proposal where the abstract on NSF's website may not have a full description of the science you're after, you may need to explain more how that is part of the proposal and correctly part of that proposal. The panel will ask if it's not obvious to check with our NSF program officer to say, hey, is this part of that proposal that we can't see? And they will, the program officers will confirm that for them. If there's any question on eligibility, this is a very uncommon case that it's not clear that you're eligible. Make sure that it's obvious you are eligible. This is an uncommon situation. And finally, again, I'll emphasize this, they aren't looking to review a science proposal. You've already done that and cleared that hurdle through NSF. They only want to see enough science to enable them to justify whether the computational experiments you've laid out are adequate and justified. So on justifying the computing needs, a little more detail here. For Cheyenne, this has a long history and pretty well defined in the instructions. You want to talk about the cost of the runs necessary to carry out the experiments supported by benchmark runs or published data. If you're using a well-defined and publicized CISM case, for example, you can refer to the CISM timing tables. If it's an uncommon one or one that's tailored to some code you've written, you'll need to provide at least some evidence that you understand, that you have some justification for the costs you're asking for. Typically, a table is provided, one row per experiment that says, here's runs, this is the number of core hours, this is how much we need. The Cheyenne allocations are made in core hours. In this case, it's the number of nodes you run on times the 36 cores per node times the job duration in hours. So add up all the jobs, the duration of those, the number of nodes that you need to run each job, and you can work out the calculation. I'm happy to help that with those kind of questions, but it is provided on the Cheyenne website. For Geyser Caldera, in most cases, I would suggest asking for 5,000 core hours in order to do your data analysis. That's sufficient for most projects by and large. If you've got a large-scale project you've already done and you know that you've used more than that previously, you can say, in my prior work on similar to this, I used this many core hours, and you'll probably grant that. Very few projects have ever used more than 10,000 Geyser Caldera core hours. And we generally just accept requests that say, hey, I actually did use my 5,000, please, may I have some more? And we'll typically grant that on request. In fact, I want to emphasize too, Geyser and Caldera use is encouraged in order to save you time and effort in transferring data off-site or post-processing data before moving it to longer-term storage. We do want you to provide these services to help you minimize your data footprint. Now, storage needs, I can spend a little more time here because this is newer. We want to make sure users have the right amount of information. And as I mentioned before, the larger your data footprint, the more important this aspect becomes. You want to relate your storage use, the use of our storage resources, to the overall workflow and the timeline of your computational plan. For university requests, they may span 3 years. So think about where your data will be at each point along the way during your allocation award. If you have a very data-intensive workflow, a lot of data being produced by modeling runs, you should also show that you're using storage resources efficiently, meaning you want to minimize the periods where you just have large amounts of data sitting idle on the Glade file systems. That might be used by putting it to the side in our campaign storage to be made available. But you should also consider, how can I minimize the amount of data movement in this overall project? You don't want to have a project where you do a lot of runs, move it to one location, wait for a while, move it back, do a little bit of work, have to move it back to a resource again. You want to try to be efficient in the amount of data movement you do, because that does take your time and makes the process more complicated and involves having being more predictable as to how much data we can make available, how much storage we can make available to others. Next, we need more details in many cases, especially as projects get larger with their data footprints, how you'll be generating that data and what will be generated and what will be kept. You want to relate and be clear that the data you're producing is related to the proposed computational experiments. You'll want to describe any efforts you've made to reduce the size of that data by, for example, producing only the variables that you need for your study. And you want to describe the scientific value for storing those variables in that data, right? If you're producing vast numbers of variables that aren't related to your project and your numbers get very large in terms of your data storage, the panel will start questioning, why are you producing all this and what's the anticipated need for that? And in the supplementary document, your data management plan, you do have some space there to provide some additional details. And how are you going to share that data long term? What's your plan for managing it longer term? And this is not only during your time at CISL resources afterwards. If there's details on the analysis of it that makes sense to include, or how you're planning to preserve this long term, any of these details that may affect why you need the amount of storage you're asking for, that's a good place to include some additional information. On project requests, again, you only have to ask for specifically a request for project space in your application request. You don't need to ask for scratch space or your home directory or your workspace. Those will all be available to you. And keep in mind that we do allow you to submit a help ticket after you get started to increase the size of your scratch space. That's a separate request, usually with a minor explanation that, hey, my output runs produce more than the 10 terabyte default, so I need to have a little more data storage there. That's typically handled very quickly. But project space is permanent. Typically, it lasts for the duration of your NSF award. And that's a lot of disk, and there's an opportunity cost, obviously, for other projects that can't use that space. So in asking for a project space, you want to explain why you can't use scratch space. A common refrain we often hear is that I'm worried that the scratch retention period isn't long enough to let me put all my data there forever, which is true, and that kind of justification is a bit simplistic and not really going to be sufficient. And again, in the past we said as long as you even acknowledge that you know what scratch space is and it's different from project space, that was actually a great step forward, but that's not going to be sufficient for very large projects. Again, we want you to think about the whole workflow over the course of your project to say, how am I using the data storage resources effectively to both minimize my data footprint, minimize the amount of data movement between resources, and to help me accomplish this workflow in an efficient fashion. Glade project space can be used for a range of needs, but that's up to you to tell us why you need that space. For a lot of them, we do realize that campaign storage, which will be available again. It may ultimately be a better solution, and we'll work with you if that turns out to be the case during this year. Okay, back to HPSS. We still have a 20 terabyte default limit for large-scale allocations for the university. So if you think you need a modest amount and up to 20 terabytes is considered modest, you can just ask for that, and it says, yes, you can put that much data on tape. And again, I'll remind you that the university policy is still that HPSS should be limited to the duration of the funded NSF award. We do make some exceptions to go slightly beyond that, but it is not a long-term perpetual home. While using the tape, and again, I'm thinking here more in terms of stuff above the 20 terabyte default limit, but you want to demonstrate that your HPSS use is efficient and appropriate. We don't want to see you storing every byte you generate to tape. That's not an appropriate use of HPSS, just to store everything there. Have you done your post-processing first? Have you filtered out variables that you stored temporarily that you won't need long-term? Have you done any other processing to compress it, for example, using NetCDF compression or, and so on? How have you reduced that footprint that's going to be preserved on tape? You want to make sure, we don't want to see you using HPSS as a temporary file system. Well, Scratch is full, so I'll put it on tape and then I'll get it back later. That's not going to be appropriate. And we certainly aren't making many cases where you will have both project space and a duplicate copy of the data on tape as well. That is highly unlikely unless you make it a very high level, a very compelling justification. And keep in mind, if you've computed with us before and you still have data on tape, we do like to hear that you acknowledge that, yes, I'm already storing a certain amount of data on tape and this is why it is still there. So please provide a brief summary of why you still have that data around and what's your time frame for deletion or management of that data on the system.